what do you think about all the AI development, specifically in robotics? How can they benefit from this actually?
Well, of course, it depends a bit on how you approach those problems. Do you want to build bio-inspired robots, or do you just see it as an engineering problem in which you just try to utilize the correct sensors and add them to your robot and try to solve a control problem? I think there's a world to gain by trying to make the connection between how humans behave, move, perceive perhaps, and trying to incorporate that into robotic devices. And that's subfield of AI, right? Trying to develop these more these robotic devices or robots. If you talk more about machines in general, then often the interest is also going in what kind of algorithms do we need to develop? And, can we take benefit of brain function on how to develop these algorithms, or can we use these algorithms in order to decode brain function? And take, for example, artificial perception, a perception in an AI system.
Yeah.
How do you want to develop it? Well, do you want to mimic how the human brain does it? And that means that you're building neural networks. And that's what people have done. But now people see, well, you have to build these deep neural networks, deep learning, multiple layers, as we see in the brain, in order to set up vision. And so you see that there's lots of borrowing back and forth. And I think that makes the link between AI and neuroscience quite strong.
But what would you say so the one big criticism I heard from the academic side about these deep neural nets that are being used in industry just almost as a one-size-fits-all solution. Like, we have a problem. Just train a deep neural net. It's fine.
Yeah, and then if you have not a problem, train another deep neural net.
Yeah.
And that's a bit of criticism. But of course, I think the AI field is working on that. One-shot learning.
Right.
Yeah? And we call that's how it's called. Can we learn from just giving one new example, as the human brain tries to do, or in a few examples, right? We can generalize quite quickly. Well, there's all these examples, and how deep neural nets can go wrong if it's trained on pictures of cats, and you still see, as I would still recognize as cat, but it's slightly different, and the whole deep neural net is already goes awry, right? It's completely off. But I also have somehow, and I don't consider myself a deep expert there, that the field will go solve that. Yeah. The question still is, do we in the end understand more about brain function?
Right.
Yeah?
Right.
That is and it's even a philosophical question.
Yeah. I think it goes back to a question of the difference between the theoretical understanding and the application. Yeah. Because I see a lot of people that like to have this in their arsenal of tools, but they don't care if they understand a bit better how the human brain works. They couldn't care less.
Yeah, exactly.
They just I have this toolbox and I just use it to solve my
of course,
problem.
Your categorization problem, your classification problem, whatever your problem is, right?
Yeah.
And that's totally valid. The question is, I think for academia, it's more important to develop new algorithms, not
for these deep neural net training.
I don't think that in academia we should build self-driving cars, right? Because the whole industry is working on those questions.
Yeah.
But what academia can do is trying to push the science forward, right? New algorithms, new techniques.
You mean new algorithms as in how the deep neural net can be trained?
Yeah, the whole field of machine learning.
Yeah.
Let's develop that from a more theoretical side. Yeah, and of course, if we train students, people in those fields, they can also bring it into society, right? And of course, we can make the connection to society. But I see that more as the purpose for academia than really trying to start competing with
industry,
all these developments that are already going on in society.